Now we have a condition. This is a cross section given. There are two types of stresses are here, sigma 1, sigma 2. These are normal stress, and there is no shear stress on any plane. This is the scenario, and we have a oblique plane which is CF at an angle theta with vertical plane BC. We have to find stresses on this CF. So stresses can be found out along the plane and perpendicular to the plane or normal to the plane. So in previous classes we have learned the analytical method. Today we are going to learn the graphical method. So for graphical method we need Mohr cycle. Now to draw any circle we need some minimum informations, like at least 3 points on the periphery or any one point as center and the radius, or any diameter. So here while we draw the Mohr circle we will remember 2 points. Point number 1, every point on that periphery of the circle will represent a plane in the cross section. So and the second point is the planes making theta angle in the cross section or in the original image will make 2 theta angle on the Mohr cycle. So if there are two planes making theta angle in the original situation in the diagram, in Mohr circle it will make 2 theta angle. This is the 2 point you need to remember. Now if we look at the images AB and BC plane, this BC plane carrying sigma 1, AB plane carrying sigma 2, making an angle here is 90 degree. So from just previous to discussed point we can say that this AB and BC plane will be on Mohr circle making angle 2 theta between them, as here they are making 90. So in Mohr circle they will make 180. So now when these two planes make 180 and these two planes will be on the periphery, on any point on the periphery of the Mohr circle, so that means this AB and BC will give us the diameter of the Mohr circle, as because they will have 180 degree between them and both AB and BC plane will be on the periphery of the Mohr circle. So that's why you can say this AB and BC will give us the diameter. Now we have to locate the direction of the planes AB and BC on the Mohr circle. So now here we are assuming that sigma 1 is greater than sigma 2. So if it is so, this BC plane carrying stress condition as only normal stress is there, so is sigma 1 comma 0, and this AB having stress condition sigma 2 comma 0. So now if we locate these 2 points sigma 1 comma 0 and sigma 2 comma 0, let us see where it becomes. Here it will be sigma 1 comma 0. So P point on the periphery will represent the plane BC, and this Q point here, this Q point will represent the plane AB. Now this PQ is our diameter of the Mohr circle. So we will divide into two halves, and this center can be found out. This is C. So from C we will draw a circle making PQ as diameter. So this will be our Mohr cycle. Now while we have located this Mohr cycle, our strategy is to find this plane on this Mohr circle. So how can we locate this plane CF? It is set at an angle theta clockwise from BC plane. So we have already found out BC plane here. Now this plane measured clockwise. We will measure clockwise from BC. We will measure clockwise. Now here if the planes are making angle theta, here it will be making 2 theta. So we will go from CP, the angle clockwise same direction but double is 2 theta. We reach at E point. So we join CE, these CP and CE making a 2 theta angle. Now if we join OE, that will give us the resultant stress on that plane CF, because E represents CF plane. Now OD represents the shear stress on this plane CF, and this OD represents the normal stress. So OD represents the normal stress on plane CF, DE represents the shear stress, DE represents the shear stress, and OE represents the resultant stress. Okay. Now we will discuss the same thing with another image, and we will compare this graphical method with the result of analytical method. Basically we will do the same thing but with a different example, so that the thing become more clear to you. I have drawn it previously to save the time. Let us have BC here. So now you see the stress condition. There are two stresses horizontally at x direction, sigma x, and vertically along y direction the stress condition is sigma y. Both are tensile. Now we have to follow the sign conventions while we will say the tensile stress will be positive, compressive stress will be negative, and shear stress clockwise is positive, shear stress counterclockwise is negative. We are taking this sign convention. Now this case, this is a cross section BC having the stress condition sigma y comma 0, AB having stress condition sigma x comma 0. Now if you look at this image here, this point gives us the sigma y, this point gives us the sigma x. So this point is basically sigma x comma 0, this is sigma y comma 0. If sigma x greater than sigma y, we are assuming, then this is sigma x, this is sigma y. Now so we are getting AB and BC having 90-degree angle between them. So here they will be at 180 degree. Here the angle made with this plane having theta counterclockwise. So our job is to find out the normal stress and the shear stress on this given plane. Now we will locate this sigma 1 or sorry sigma x here, sigma y here. So we will making a circle, making these 2 points as diameter. Now this is our Mohr circle. when we draw the Mohr circle, how can we find this plane? This is at an angle theta counterclockwise with BC. Okay, so BC is here. So from here, this is theta. So we'll go to theta. So counterclockwise, we have gone to theta. So now we are getting this plane. And here, at this point, this plane can be denoted. Say this is, so just give it any name, PQ. So here we'll get another plane, say M plane represents this PQ. So now, so from origin to this point we are drawn perpendicular. So from origin to this point will be the normal stress on this plane. From here to here will be shear stress. From the length of this perpendicular will be the shear stress on this plane. And if we draw from here to here, so that will be the resultant stress. Okay, now if you are asked to find out the principal planes, what are the condition of principal plane? At principal planes, the value of shear stresses are 0. So here at these 2 points, this principal stress can be found out, because at these 2 points shear stresses becomes 0. Now, so if we find out the values and compare them with analytically, let us see what we can get. What are the values we can get from these values of sigma n, normal stress, and tau? Let us see. So we said this is sigma n. How can we find it out? Let us find out this coordinate point of C point. C point will be found out this much is sigma y plus this much is radius. Okay, so how can we get coordinate of C point? This much is sigma y plus radius of the Mohr circle. Okay, now so this much is sigma y, we have written sigma y, plus radius of the Mohr circle is how much? This is sigma y, this is sigma x. So this much is sigma x minus sigma y, and this much is sigma x minus sigma y by 2. So sigma y plus sigma x minus sigma y by 2, and there is no shear stress, so that's why it is 0. So this is sigma y plus this much is sigma x minus sigma y by 2. Sigma x minus sigma y by 2. So from simplifying we will get sigma x plus sigma y by 2. So this OC is how much? Sigma x plus sigma y by 2. Now the radius of this Mohr circle is sigma x minus sigma y by 2. This is the radius, sigma x minus sigma y by 2. Now then, what will be this value of sigma n, okay, or normal stress on the plane? How can we get this sigma n? So sigma n will be equal to this much minus this much, this much. So this much is equal to, you see, r cos 2 theta. This much is r cos 2 theta because the angle is 2 theta at C, and this is the radius r. So sigma n can be found out OC minus r cos 2 theta. So sigma n can be found out OC, which is sigma x plus sigma y by 2 minus r cos 2 theta. And what will be the value of shear stress or tau at an angle theta? So here, this much from here to here will be the tau. This much will be equal to r sine 2 theta. So this is r sine 2 theta. Now if you compare these two values with analytical method, you will find the values are same. So I hope this is clear for everybody. Give me a reply. Okay, so now we will continue on the next topic. In this case, we have tensile forces along x direction sigma x, along y direction sigma y. These are stresses. Okay, these are not forces, these are stresses. Do not get confused. These are stresses. Along these normal stresses, there are shear stresses present. Look at plane MN, there is a clockwise shear stress present. Now, if shear stress present in any direction, the principle of complementary shear stress that we have learned previously, we can remember that to counter that shear stress, there will be another complementary shear stress of same value but in opposite direction will be working from the other plane. So if at MN plane there is a clockwise shear stress present, to counter that on a PN plane there must be another shear stress of equal value but in opposite direction. So in MN there was clockwise, so at PN there will be counterclockwise of same value shear stress. Okay, now as we have this stress condition, we will try to draw the Mohr cycle. I will discuss very slowly. So now Mn, this plane Mn having stress condition is sigma x comma tau. Clockwise we said shear force, shear stress clockwise positive, okay, and shear stress counterclockwise negative. We will follow that sign convention. So Mn, this Mn plane having stress condition sigma x comma tau, and this Pn having stress condition sigma y comma minus tau. Y minus because the shear stress here is counterclockwise. Okay, so we have two planes at an angle 90° that should be represented on Mohr circle at an angle 180°. So when we locate Mn and Pn on the periphery of the Mohr circle, we can draw the Mohr circle. So Mn and Pn will be the 2 points on a diameter of the Mohr circle, because in between they will be having 180° angle. So now Mn is sigma x comma tau. We will locate it here. Up to this point it is sigma x, and if we draw tau shear stress, we know along this there is shear stress and along this there is normal stress. So from here we will go tau amount and we will reach at point C, and similarly we locate sigma y here and minus tau here. So similarly D point represents Pn and C point represents Mn. So when we get the CD, we know that we have found the diameter of the Mohr circle. Now we take these 2 points and draw a circle. That will be our Mohr circle. Okay, up to this point clear how we have got Mohr circle? Okay. So now in previous diagram we have found out how to get stress and shear stress and normal stress and resultant stress values on Mohr circle. Now from in this figure we will find out how to find shear stresses. So looking at this figure we can understand that we will find out principal stresses. So looking at this figure we will find that the principal stress means the normal stress at a plane where shear stress is 0, that is principal stress. So to find principal stress we need to find principal plane, and to find principal plane we need to equate shear stress equal to 0. So on this circle shear stress is 0 at this point and at this point. So we call this point as point 1, we call this point as point 2. So if we find out normal stress at point 1, because shear stress is 0 here, then we will get major principal stress. If we can find out normal stress at point 2 here, we get minor principal stress. So our job is to find out this sigma 1 and sigma 2. For this purpose, we take help of the geometry. Sigma 1 can be written as OO dash plus R. Look, this is OO dash plus this is R, radius of the Mohr cycle. Okay, so this is OO dash, this much, plus the radius of the Mohr cycle will give us sigma 1. Similarly, this sigma 2 can be found out OO dash minus radius of the Mohr circle. Is this same to everyone? There is no audio. Okay, give me a moment. Hello. 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 Okay, so we have discussed that point 1, it will be sorry, point 1, this is our major principal stress can be found. At point 2, minor principal stress will be found. So we need to find sigma 1 and sigma 2. Sigma 1 is, look at here, sigma 1 can be found here. So this is O dash plus radius of the Mohr circle. Similarly at point 2, this is O dash minus radius of the Mohr circle. We will discuss the class test after the class. So is this point clear? How can we get the values of sigma 1 and sigma 2? Is these 2 points clear? Sigma 1 equal to O dash plus R and sigma 2 equal to O dash minus R. Look at the diagram. Here we will find sigma 1 up to this point O dash plus this is the radius of the Mohr circle. And sigma 2 is equal to here O dash minus radius of the Mohr circle. Now this tau max can be found at this point if we draw a perpendicular here or here. These 2 points will give us that maximum shear stress, that will be tau max. So tau max will have the value of radius of the Mohr circle. Now then our job is to find O dash for each of the cases. So O dash can be written as OA plus AO dash, OA plus AO dash. So again AO dash is equal to half of this this AB by 2. AO dash is equal to half of AB here. So now OA can be written as sigma y. We will write sigma y in place of OA plus AO dash is half of AB. So AB means sigma x minus sigma y, half means sigma x minus sigma y by 2 will give us AO dash. So sigma y plus sigma x minus sigma y by 2. Upon solving we get sigma x. Okay, give me a moment. The video need to be fixed. Okay, so now upon simplifying we get sigma x plus sigma y by 2. This is OO dash. This is OO dash. Now we need to find the radius. Okay, so how can we find the radius? Look at the image. This is the radius O dash C. This becomes O dash B square plus BC square. So O dash B, this much is basically equal to AO dash, and that is equal to sigma x minus sigma y by 2 whole square root over of. So this is basically the hypotenuse of the triangle, right angle triangle. So square of O dash c square is equal to O dash b square plus bc square. So O dash c will be equal to root over of O dash b square plus bc square. So O dash b square is actually sigma x minus sigma y by 2. So here sigma x minus sigma y by 2, this much whole square plus this is tau. So this is tau square. So when we get r, when we get o dash, now then sigma 1 will be equal to o dash plus r. So o dash value here sigma x plus sigma y by 2 written here plus the radius root over of sigma x minus sigma y square by 2 whole square, sigma x minus sigma y by 2 whole square plus tau square, and sigma 2 will equal to just having a minus sign here from this formula o dash minus r. So now the tau max will be the radius. So radius we have found out. So tau max will be equal to root over of sigma x minus sigma y by 2 whole square plus tau square. So is this clear how to find out the principal stresses? Now if we compare these values of sigma 1 major principal stress, sigma 2 minor principal stress, and tau max, we will find them same as we have found in analytical method. Simple geometry. Is it okay? Look at this Mohr circle. Look at this Mohr circle. Where is sigma 1? Here, normal stress at point 1 where the shear stress is 0. Here shear stress is 0, and here shear stress is 0. So at this point, the normal stress measured from origin to this point 1. So how can we get this value? O dash plus O dash 1. So this is basically the radius. This much is the radius. This is O dash plus R. Here O dash minus R. I hope it's clear now. Avronil, any issues?
No, sir, understood, sir.
Okay, fine. So now we have learned both the methods to find out the principal stresses on analytical method as well as graphical methods also, and you can find out any planes. Suppose in this figure any plane is given, I think you will be able to find out the relevant shear stress and principal shear stress and normal stresses. So we will continue on um, on next topics. We will try to solve few more problems. Give me a moment. Okay, uh, we have at least more than a week left before examination, so you have enough time to practice. And for that purpose, we will include this principal stress chapter also. So it will be the syllabus for the um, internal one will be the module 1 plus this principal stress from module 2. So module 1 in full plus principal stress and strains.
Hello, sir.
Yes.
Sir, up to principal stress and strain.
Yeah. Module 1 plus principal stress strain from module 2. Here, this is your syllabus. Module 1 is completed, and from module 2, we will have only principal stress strains. Here, transformation of stresses in two-dimensional problems, principal stresses, maximum and minimum normal stress, maximum shear stresses, Mohr circle of stress, only this much. The thing just we have practiced.
So will we have anything from SSP search class?
Please come again, little louder.
So will we have anything for the exam from SSP search class also?
Yeah, um, that portion will be told by your SSP sir.
The
Otherwise,
SSP sir already told in the last class.
Okay.
okay, then my portion plus combining his portion will be the total syllabus for the internal one. What he have given up to torsion?
Yes, sir, he told up to last class.
Okay, so fine. I think the internal syllabus is clear now. We have a lot of time left. We must prepare hard. Okay, so okay, we do not have much time left. We will go for a very uh, quick formation of a problem. Okay, the question, I'll read it out. You take short notes. At a certain point in a strained material, the intensities of stresses on two planes at right angles to each other are 20 Newton per millimeter square and 10 Newton per millimeter square, both tensile. They are accompanied.
Sir, please repeat, sir.
No, there will be no change in the pattern. 10 number of multiple choice and 2 questions of 10 marks. Yeah, just give me a moment. Yeah, at a certain point in a strained material, the intensities of stresses on two planes at right angles to each other are 20 Newton per millimeter square and 10 Newton per millimeter square, both tensile. So from here we can get sigma 1 or say sigma x is 20 Newton per millimeter square, sigma y is 10 Newton per millimeter square. Now, both are tensile. They are accompanied by a shear stress of magnitude 10 Newton per millimeter square present. Find graphically or otherwise the location of principal planes and evaluate the principal stresses. So this is the given data. From here you have to draw a Mohr circle and find out principal planes and principal stresses. So what you will have to do, draw the Mohr circle. This is normal stresses, this is shear stresses. So from you can take a 20 Newton per millimeter square and 10 Newton per millimeter square. So you can take 1 centimeter of scale represents, so 1 centimeter of length represents 2 Newton per millimeter square. Okay, so that means sigma x can be represented by 10 cm, sigma y can be represented by 5 cm, tau can be represented by 5 cm. Okay, we have only 5 minutes left. So if the connection goes cut it out, must rejoin if we cannot finish before this time. So from here sigma x can be drawn like this. This is a 1 2 3 4 5 6 7 8 9 10. So here will be sigma x, and 1 2 3 4 5 here will be say sigma y. So this is 10, this is 5. So now we will draw a circle. Sorry, we will not draw the circle because there is shear stress. So if shear stress is here, it is not given along which direction it is, clockwise or counterclockwise. So you can take any direction. Okay, direction is not given. So you just take from sigma x, you can take positive or negative because it is not given. You take 5 centimeter, and here from here you can take 5 centimeter. Okay, so these are the two planes having 20 comma plus 10, 10 comma minus 10. This will be 20 comma 10, this will be 10 comma minus 10. Okay, now if you join them, this will be your radius, and while you make the circle, this will be your Mohr circle. At this point and then this point you can find the principal stresses. So from, if you measure this angle, you can get this major principal stress. You measure with scale this much length and convert from this 1 centimeter equal to 2 Newton per millimeter square. So this much length will be become how much centimeter, and then by multiplying it with 2 you can get this major principal stress, and by measuring this angle with help of protractor you can locate this major principal plane. So remember this is 2 theta. So when you write the answer, you have to divide it by 2. Similarly, to measure minor principal plane, you have to measure from here to here and multiply with this conversion constant 2 Newton per millimeter square. So you take the length, multiply it with 2 Newton per millimeter square, will give you the stress at this point, the stress at minor principal stress point, and as well as this angle is 2 theta, so divided by 2, and then we can say this minor principal stress is measured along this direction, which is clockwise from here. So if it is 2 theta, you have to tell that the principal plane at an angle of theta from this point. Okay, is this clear? However, in the next class we will solve few more problems on this topic. Is the problem clear to everybody?
Sir, do we need to join again?
No, you are not required. If you understand, we can end it here.
Okay.
Any questions on this problem? How to solve it? Is it clear to everybody? Give me an answer. Okay. Obronil? Cannot hear you.
Hello, sir.
Please.
Yes, sir. It's clear, sir.
Okay, fine then. In the next class, then we will do another problem. We will solve another problem. So here we stop here today. We'll meet you